Latch is a type of type of temporary temporary storage device device that has two stable state that has two stable state two stable states, and two stable state is called bistable 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 and and is normally placed in a category separate from in a category separate from that of flip flop that of flip flop that of flip flop. So latch are similar to flip flop because they are bistable device and that can reside in either of two states using a feedback arrangement, and in which the output are connected back to the opposite input. Yes, so I'm saying a latch is a type of temporary storage device and that has two stable states. Due to two stable state, it is called bistable, and it is normally placed in a category separate from the flip flop. Separate from a flip flop. So similar to flip flop, I'm discussing a different type of flip flop like SR flip flop, JK flip flop, D flip flop, and T flip flop. Similarly, where discuss the SR latch, uh, JK latch, D latch, and T latch like this. Is that clear? So now the next point, coming to the what type of configuration in the SR latch, or what are the difference in the SR flip flop. So when I'm draw SR latch, so this is SR latch SR latch. That means what is the meaning? That means set reset set reset latch. SR latch means set reset latch. So how to design? So it one is designed using a NAND gate or using a NOT gate. Using a NAND gate and NOT gate. So NOT gate. So if you want to design this one in the using, so when we have want to design using NOT gate, NOT gate. So what happens? So concept is this is a bistable. That means two stable state. That's why it is called a multi-vibrator. Multi-vibrator. So when we have designed the NOT gate, so suppose this is a NOT gate. This one is a NOT gate and having one state and another state. That means suppose here the input is 1, so output is 0, and then again here we have connected the another NOT gate, and it's the output is come back to as a input Yes. So suppose that here the values is let's say uh, input is 0. So what is the output here? 1. And again the output of this inverter is 0. And this 0 is come back to here 0. And again this cycle is repeated. Or you can arrange this method. So you can arrange this one as a one NOT gate is here, one NOT gate is here, an input of this one. Now we have connect here the one NOT gate and like this one. So two NOT gate is connected. So this uh, first NOT gate output, that one is the connected to the input of second NOT gate. So first NOT gate output connected to input of a second NOT gate. Yes, like this. And similarly, the output of a second NOT gate, that one is the input of a first NOT gate. So output of a second NOT gate, that one is the input of a first NOT gate. Yes. So it's a connection is look like this one. Yes or no? So this connection you can arrange like this. Arrange like this. So when you have design using a NOT gate, so we can arrange like this one. Yes, and suppose if you want to design this one using NAND gate. So this one is the SR latch. So now I'm design SR latch, set reset latch. So suppose I'm designing using NAND gate, using NAND gate. So how to design this one in the NAND gate? So one NAND gate is connected here. This one is the NAND gate, and this is the output. And the another NAND gate is this one. This one is the output, and this is the input. So two NAND gate is connected, and this is called set S. This one is reset R, and here the output is, suppose this output is Q and Q bar, and output of first NAND gate, that one is connected to here, and output of second NAND gate, that one is connected to here. Yes, so this is called SR latch. SR latch. This one is called SR latch. And then here write down a truth table. Truth table. So here S is one input, R is another input, and output is Q. Output is Q. So if both is 0, 0, that state is called invalid state. Invalid state. 0, 1, values is 1, 1, 0, values is 0, and if both is 1, 1, output is previous state. Previous state. This one is invalid state. This is a truth table for SR latch. Truth table for SR latch. So up to this point, anyone have any doubts, any query? Yes or no?
No, sir.
So this one is the circuit diagram, and this is truth table of SR latch. Now next, uh, SR latch using NOR gate, using NOR gate. So when we have designed using a NOR gate, so using, just now I'm writing SR latch, SR latch using NOR gate, NOR gate. So how to design this one? So this is how to design the SR latch using NOR gate. This one is a NOR gate. This one is a NOR gate. So this one is S and R is input and output is QQ bar. So this is called a NOR gate. So here I am designing a SR latch using NOR gate. And in that case, what is truth table? Truth table is truth table is uh, input is S and R and output is Q. Output is Q. So two input, total four combinations, both is 0, 0. That state is called previous state. Previous state. When 0, 1, output is 0. When 1, 0, output is 1. And when both is 1, 1, that condition is called invalid. Invalid state or invalid conditions. So this one is the truth table of SR latch designed using NOR gate. Yes, is that clear or anyone have any doubts? And this SR latch is used. So what is the application of SR latch? The application of SR latch is so applications of SR latch. So first application you can say SR latch is used. SR latch is mainly used as a memory element in digital circuit. Digital circuit, and it is also used to eliminate bounds in switch in switches or keyboard. Keyboard SR latch is used. SR latch is used. So up to this point, anyone have any doubts, any query? Yes or no? Is that clear or anyone have any doubts, any query? Everyone give your response. What is a flip flop? Flip flops. So basically, what is flip flop? Flip flop is a sequential circuit. That one is stored a memory device. They can store a 1 bit memory. So simply you can say a flip flop is a basic basic memory element. Memory element. Basic memory element. It can store 1 bit. It can store. It can store 1 bit 1 bit, uh, having two having two stable state having state two stable state. Hence it is known as bistable multivibrator. Two stable state, that is called 0 and 1, that is the two stable state. Hence hence it is known as hence it is known as bistable bistable multivibrator. Multivibrator. Hence it is called a bistable multivibrator, and having two output output having two outputs which are which are complementary to each other, which are complementary to each other, each other. This this is the basic feature of a element. So flip flop having two stable state. Two stable states means one stable is zero and another stable is one. Two stable state. That's why it is called. That's why it is called mul- bistable multivibrator. Bistable multivibrator because it's having two stable state and having a two output and they have a complement to each other. They have complement to each other. So up to this point, anyone have any doubts, any query? Yes. So basically, these flip flop is uh, flip flop. This flip flop is a different types of flip flop. So one of the flip flop is called SR flip flop. Another one is JK flip flop. Next is D flip flop, and next one is uh, T flip flop. So total four types of flip flop. Four types of flip flop. So first now I am discussing with you SR flip flop. SR flip flop. Yes. First now I am discuss with you SR flip flop. SR flip flop, or also called a set reset flip flop. They can design using you can design using a NAND gate. So when you have designed using a NAND gate. So how to design using the NAND gate? So this one is a NAND gate. Here one input, here one input, and then here you have connect feedback. Yes. So this is look like a latch. So suppose this in output is Q. I'm saying a flip flop having a two output or latch having a two output. So if and both are complementary to each other. So if this one is Q, so its value is equal to Q bar. So complement to each other. And this is a latch. Now this one is convert to a flip flop. So here we have connect a clock. So one NAND gate is connected here. One NAND gate is connected here, and then here the input is S, here the input is R, and here the input is equal to this one is clock. So this is called SR flip flop. SR flip flop. So this portion, what is this portion? This one is the latch portion, and here we have apply a clock. Here we have apply a clock. So in this way, you can design a SR flip flop using NAND gate, using a NAND gate, or you can design SR flip flop using a NOR gate. So how to design a NOR gate? So SR flip flop, SR flip flop using NOR gate. Second one is using NOR gate. So you can design using a NOR gate. So one NOR gate is connected here. One NOR gate is connected here. Output, two input. Output, yes. So this one is a latch, and before that we have connect the no, clock pulse. Then this one is work like a flip flop. So this one is a latch, and output is equal to qn. Suppose output is qn. So this is qn bar, or simply I'm writing here the q. No, not right here. So I'm writing a q. So this value, if output is q, so this output is q bar, complement to each other. And here you have connecting uh, one AND gate, and its the output is connected here. The output is connected here, and this another input of AND gate is clock, clock, and here the input is S and R, S and R. So this is called SR flip flop using a NOR gate. So up to this point, anyone have any doubts, any query? Yes. Everyone give your response. Are you understood or not? Yes. Then here I am writing a truth table. Truth table for SR flip flop. So this one is clock. This one is clock. Then S R and QN plus one. Yes. So meaning is, so when the clock pulse is 0, so when you apply the clock pulse 0, that any value of S or any value of R, output is in Qn. So what is the meaning of Qn? Qn means memory. Memory. That means initially if in memory is 0, then 0, and if initially in the memory is 1, then 1. Yes, so this is called a memory, and what is the meaning of previous state or like that? And another method, another way is when clock pulse is one, so it's a depend upon the combination of SR. So it may be both is 0 0. So when both S and R is 0 0, then its state uh, Q of n. This is called memory or previous state. Previous state. And when the clock pulse is 1, then its SR it may be 0 1, and when the clock pulse SR may be 1 0, or when the clock pulse then SR is 1 and 1, according to find it the output. So S is 0, output is 0. S is 1, output is 1, and both is 1 1. So this is called invalid state, or unused state, unused state, invalid state or unused state. This is called invalid or unused state. This zero is called a reset state, and this one is called a set state, and qn simply called a previous state. And what is the meaning of previous state? So here I am writing a Qn, and here I am writing a Qn plus 1. So Qn is a previous state of Qn plus 1. So that is the concept of a previous state. So anyone have any doubts? So this is a very important, remember that. Anyone have any doubts, any query? Yes, in a truth table. Everyone give your response. Is that clear or not?
Yes, sir.
So in this way, when you have designing using a NAND gate, or when you have designing using a NOR gate, this is the truth table of SR flip-flop. Now we discuss with you a characteristic table. Characteristic table. Characteristic table. So how to find the characteristic table? So one is S, another one is R. Writing here a Qn and Qn plus 1. Qn plus 1. This is the different states. Different state. So here the values is uh, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, double 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Yes. So what is the value when the in the truth table of SR flip flop, when S is 0, R is 0, what is the value of Qn? Qn plus 1 is, just to see that. I'm saying when S is 0, here the clock pulse is 1. So when S is 0, R is 0, what is the value of Qn plus 1? That is Qn. Yes, similarly when S is 0, R is 1, 0, like this. So complete this characteristic table. So what is the value of this characteristic table? So when S and R is 0, 0, output is Qn. So what is the value of Qn here? 0. Similarly, when S is 0, R is 0, what is the value of Qn plus 1? That is the Qn. So its value is 1. So you can complete like this one. So what is the value? When 0, 1, that is called 0, 0. When 1, 0, this value is 1, 1. And when 1, 1, so that condition is called invalid state. So I'm writing here don't care. Here I'm writing don't care. Up to this point, anyone have any doubts, any query? So this is called a characteristic table. And then the next part is find the characteristic equations. So how to find the characteristic equations? So that equations is find through a characteristic table. So now I'm solving a three variable K map. So three variable K map, and here the input is SR. So simply called SRQN. I'm writing in a sequence, and its values is 0, 1. This is the 0, 0, 0, 1, 1, 1, and 1, 0. So where is the 1? So 1 is here, 1 is here, 1 is here, and then 2 don't care. So 1 is at the place of 0, 0, 1. So here is 1, 1. Just I'm marking here. Here is 1, 1. Another one is 1, double 0. So here 1. Another one is 1, 0, 1. So here 1. And 2 don't care is at the position of 6 and 7. So at the position of 6 and 7 don't care. Yes or no? Don't care, and just now start mapping. So one of the mapping, one of the mapping, that one is these four is a combinations. These four. So what is these expressions? This one is S, and another one is another combinations is this one. So what is the value of this? This one is the 0 1 contradict here R bar Qn. So simply you can say the SR flip flop characteristic equation is equal to S plus R bar Qn. S plus R bar Qn. This is the characteristic equations of SR flip flop. Remember that how to find the characteristic equations. I hope is that clear to all. Yes or no? So this, yes, and this state is called reset state. Reset, and this one is called set state, and 0 1, that one is called hold. This one is called hold, that is Qn, and this state is called invalid state. This is invalid state. Invalid state. I hope is that clear to all, or anyone have any doubts, any query up to this point, or anyone have any doubts, any query in this point? Yes or no? And the next point is excitation table. Excitation table. So how to write down the excitation table for flip flop, SR flip flop? So SR flip flop, suppose previous state is called Qn, next state is called Qn plus 1, and S and R. Yes. So it's the combinations. I'm writing these combinations. It's maybe these two values is 0 0. It may be 0 1. It may be 1 0, or 1 1. So according to that, I'm writing here the output. So output is when 0 0 0 0, S is 0, R is don't care. Just check it. Check it. It's a characteristic table. So SR is 0 0, S is 0 0. What is the value? Just see here the what is the combination. So 0 0, again 0 0 is where 0 0 means S is 0 and R may be 0 1. That's why don't care. I'm writing a don't care citation table. So 0 don't care, and then 0 1 means 1 0, and 1 0 means 0 1, and where 1 1 is choosing, that values is don't care 0. So this is the excitation table of uh, SR SR flip flop. SR flip flop. And then the next point is state diagrams. State diagrams. State diagram. State diagram is having a two state. One is 0, one is 0, and another state is 1 1. So when you have going from 0 to 1, 0 to 1, that means S is equal to 1 and R is equal to 0. And when going from 1 to 0, that means S equal to 0 and R equal to 1. And when going from a 0 come back to 0, so in this case S is 0 and R may is equal to maybe 0 or 1, that is the don't care. And when coming from 1 to 1, so in that case S is equal to don't care and R is equal to 0. So this is the state diagram of SR flip flop. So up to this point, anyone have any doubts?